Hello and welcome to TI Precision Labs. I'm Nicholas Malone from TI's High-Speed Signal Chain Group in Silicon Valley. In this series, we're going to discuss signal conditioners, and in this session, we're going to talk about why you need signal conditioners. In other sessions, we'll discuss the types of signal conditioners and their differences. High-speed, multi-gigabit products are all around us. You see them in TVs, Blu-ray players, notebooks, tablets, media center servers, and hard drives. Even our cars have video infotainment systems. All of these products contain multi-gigabit interfaces. Nowadays, we easily find many electronic products using multi-gigabit technology, like USB and PCIe for higher data rate transmission, and HDMI and DisplayPort for high-resolution video. A high-speed transmission system includes a transmitter and a receiver. The transmission media between the TX and RX can be in the form of traces, connectors, and cables. Maintaining signal integrity for these high-speed signals over the transmission media is very important and quite challenging. There are many factors that contribute to the signal integrity degradation when a multi-gigabit signal passes through a transmission media. Those factors include jitter, which is any deviation from true periodicity of a digital signal. The deviation can be in terms of amplitude, phase timing, or the width of the signal pulse. Among the causes of jitter are EMI and crosstalk with other signals. Insertion loss is the reduction of signal power resulting from any loss in the signal path. For example, the longer the tracer cable, the more loss is incurred. Crosstalk is a phenomenon where a signal transmitted in one channel creates undesired effects in another channel. Crosstalk is usually caused by capacitive, inductive, or conductive coupling from one channel to another channel. Intersymbol interference is a form of signal distortion in which one symbol interferes with subsequent signals, making the communication less reliable. This is an unwanted phenomenon as the previous symbols have a similar effect as noise for the current symbol. Noise is an unwanted signal that does not carry useful information. A signal needs to be maintained in a certain signal-to-noise ratio in order to be decoded properly at the receiver end. Signal reflection occurs when a signal is transmitted along a transmission medium, such as a cable or connector, and some of the signal power may be reflected back to its origin rather than being carried all the way along the cable to the far end. Reflections happen when imperfections in the connector or cable cause impedance mismatches and nonlinear changes at the interface. Jitter can cause a display monitor to flicker, affect the ability of the processor in a desktop or server to perform as intended, or it can introduce clicks or other undesired effects in audio signals. All these factors will cause a high-speed signal to suffer signal degradations. Jitter issues can be resolved or mitigated through the use of signal conditioners. Because of the unbounded aspect of random jitter, it's not possible to eliminate all errors caused by jitter, but it is possible to achieve a targeted bit error rate, or BER. A signal conditioner, like a redriver or a retimer, can help correct jitter issues to produce a targeted bit error rate. Here are a couple of use cases for signal conditioners. One use case is extending a device's operating range. For example, a device datasheet may indicate a maximum trace length of 4 inches without the need of a signal conditioner, but the system design target requires 8 inches. The second use case is to correct a particular device's shortcomings. For example, a particular device may have an inadequate receiver, resulting in an inability to pass RX-JTAL compliance testing. This device's transmitter may have marginal performance. For example, high random jitter, subpar duty cycle distortion, weak voltage swing, etc. Here's one example of extending a device's operating range. A USB 3.1 host datasheet may specify a maximum length of 4 inches between the host and USB connector, but a form factor may require a length of 8 inches. In this example, that additional 4 inches negatively impacts the eye diagram. For this use case, a signal conditioner will be needed to handle the additional 4 inches. For this example, the IBIS AMI model for Texas Instruments TUSB 1044 signal conditioner was used to show that the length can be extended from 4 inches to 8 inches with the use of a signal conditioner. Because extending the trace length adds additional ISI jitter, a redriver signal conditioner such as the TUSB 1044 can be used. The total jitter in a system is the sum of all the deterministic jitter and random jitter. The further away from the source of the signal, the more that jitter affects the data. Jitter is broken up into 2 parts, random jitter and deterministic jitter. Random jitter is typically caused by thermal or shot noise and other unbounded sources. Random jitter is unbounded but has a Gaussian distribution. Unbounded means that there is no maximum limit. Deterministic jitter is further broken into 3 parts, periodic jitter, bounded uncorrelated DJ, and data-dependent DJ. Data-dependent DJ is further broken down into intersymbol interference and duty cycle distortion. Deterministic jitter is bounded, meaning there is a limit. A bounded uncorrelated jitter source is crosstalk from adjacent channels. The aggressor bleeds some amount of signal into the victim signal, smearing the data. Intersymbol interference is caused by frequency-dependent attenuation that occurs through a lossy medium like FR4 trace. It is also caused by reflections that occur due to impedance discontinuities from vias and connectors. Duty cycle distortion is typically caused by mismatch in a TX rise-fall time and/or clock routing mismatch in the TX path. Periodic jitter is also known as sinusoidal jitter. It's jitter that occurs at a fixed frequency. It can also be caused by power supply noise, like from a DC to DC converter, or the result of cross-coupling with an adjacent data signal. A simple form of signal conditioner is a redriver, which is an analog component that restores an attenuated input signal through equalization and gain adjustment and retransmits the signal based on signal specification. It can also shift common mode voltages. The next level of a signal conditioner is a retimer. A retimer, which includes redriver functionality, is a mixed signal component which recovers an attenuated input signal with a clock data recovery circuit, attenuates the phase and filters the random jitter, then retransmits the signal based on signal specs. There are many benefits to using a signal conditioner, including to maintain signal integrity or improve signal quality over lengthy trace or cable runs, to enable design flexibility on your PCB layout between the signal source and connector, to improve your system performance, and to help the system pass compliance requirements, to enable a broader range of interoperability, and to extend the distances that a signal can travel across cables or traces. A redriver contains a continuous time-linear equalizer that has the express purpose of compensating for ISI deterministic jitter. ISI jitter is introduced by frequency-dependent loss through a transmission media such as FR4 trace or a cable. A redriver cannot help with random jitter or non-ISI deterministic jitter. Instead of a redriver, a retimer is required if non-ISI deterministic jitter or random jitter needs to be corrected. Both deterministic and random jitter can be improved by a retimer, but it cannot completely eliminate these jitter components. A retimer will have its own intrinsic jitter, random and deterministic, and, depending on the retimer's architecture, it may amplify jitter that passes through it. Okay, to refresh your mind on what we've just covered, let's go over a short quiz and answer these true or false questions. True or false? Random jitter can be eliminated by using a signal conditioner such as a retimer. False. Random jitter is generated by natural causes such as thermal noise and cannot be removed. True or false? One purpose of a signal conditioner is to correct a particular component's shortcomings. True. A particular device may have an inadequate receiver or other impairment which degrades signal integrity. True or false? A redriver can fix random and ISI issues in a system. False. Although a redriver can alleviate ISI issues, it cannot fix random jitter. True or false? A retimer can compensate for both random and deterministic jitter and provide a jitter-free signal at its output. False. While a redriver can compensate for some deterministic jitter, it generates its own random and deterministic jitter at the output signal, so the output is not completely jitter-free. In closing, I'm glad you could join us for this introduction to signal conditioners. In other sessions, we'll show you more detail about the types of signal conditioners and their differences. Check out the TI E2E community at ti.com for answers to many helpful questions and for other key information. Thanks.